All right, good afternoon, everybody. I know we're got a number of folks that will still be coming into our discussion today. I'm excited to be your moderator. I'm Colonel Gary Haase with Air Force Research Labs. And with me today, I have a distinguished panel from industry here to talk about munitions. And I'm going to set the stage a little bit, and then I will do some, get into some introductions of our folks and let them do some opening statement introductions, and we'll get to your questions. So please type away in the question box here, and look forward to hearing your thoughts and your questions that we can throw out here and get our industry folks' perspectives here. So to kind of kick us off, I wanted to go through a thread here of understanding where the requirements come from for munitions. And so a combination, like most everything, is between a tech push and a need pull. So we have the MAGCOMs with their warfighter gaps and their near-term and readiness-focused type of needs. And then we also have to look to the future, where we have Air Force Futures, formerly AFWIC, looking at that future force design and the Air Force's future role from the concept-driven and threat-informed capability development, as well as the shift into the joint all-domain operations. So keeping in mind how munitions can enable or support those operational concepts, what weapons will allow us to do, and especially in looking at being able to connect into the broader networks. And so as we think about connecting the dots and joint all-domain operations and JADC2 ABMS, all these different ways of connecting in, weapons will be an important part of that as part of the sensing grid, where weapons can be a node and provide some ISR capabilities as they may go into a target. But we still have to have those capabilities with from air superiority of continuing to modernize our air-to-air weapons, from the global precision attack, looking at how we can have both those penetrating, survivable, long range, with that whole spectrum of effects that we need to apply to the battlefield. And lots of considerations as we look at that with how we can go with the open architectures and the agile design process to really get after the agility and be able to field new capabilities on those reduced timelines. But also from a production standpoint, as we look through the whole thing here of a need for mass and bringing mass to the battlefield, and as part of that mass, how cost plays into that, and so how we can continue to drive down cost to get more mass. So once we have kind of understand where the requirements come from, and then go to with in particular the defense acquisition community that we continue to partner with industry and really trying to reach out to small business and non-traditional folks as well, as we continue to try and be more innovative. But the primes too are also seeing that need to be more innovative and agile, and moving along with us in different concepts from the digital transformation. They're going after doing more modeling and sim and analysis, and even experimentation and prototype, and see how we can demonstrate and move along new technologies more rapidly. And so we were probably heard in a number of other areas about the digital transformation across the service. Certainly from the weapons perspective, we want to be able to provide solutions faster and be more agile, with especially as the munitions become more and more complex in a system of systems. They have all of those airframe and flight control, smart sensors and seekers, the fuses, warheads, propulsion. We certainly are looking at more networked and collaborative and autonomous systems as well, those behaviors, just as we are in other platforms. And as I mentioned, being able to communicate with one another and back into broader web and ABMS. And so we need to keep all of those things in mind as we look at the trade space between the size, weight, power, and cost, managing across that capability also of range or size aspects, and runs the whole spectrum from smaller, cheaper, swarming type of things to still a need space for the larger, more exquisite type of systems, depending on the threat that it might be going across. So we're going to talk a little bit about across all of those things, and in particular a little bit on the digital transformation for weapons and how weapons open system architectures, where we're going from the government side of the government reference architectures, or GRA, to enable us to have more modularity, so that we can have more competition and opportunity for different subsystems to come together in the all-up system perspective. And part of that too is also a faster contracting timeline. So from the acquisition standpoint, that always becomes a concern, is how we get the industry and those connected in there. So we certainly look at 804 prototyping aspects, and then looking at other transaction authorities, and broad area announcements, and a number of forums that we also need to innovate and be agile in our whole process flow there, and not just from a technology standpoint that we can insert new technologies and new capabilities, but we need to have that agility applied to our processes with contracting, but then also getting to the production aspects with that industry base, keeping the industry base healthy to provide those options, but also production capacities, as we talked, going back to the mass ideas of here getting mass on target, how industry continue to handle the capacity to meet some of those mass idea needs. So with me today, I have, I'm going to go kind of in order here, give them a little opportunity to introduce themselves, but real quick, we have Josh Goodman. He's the Auxiliary Power Unit, APU, and TurboJet Program Management Lead for Pratt and Whitney. Then I'll go to Major General Retired Storman Norman, Vice President for Customer Relations, or Customer Requirements and Capabilities with Raytheon Missiles and Defense. Then we'll have Ms. Terri Quick, Director of Air Force Customer Relations with Elbit Systems America, and then Dave Winebrener, Senior Manager with Missile and Aviation Systems Division with Dynetics Group, Leidos company. So with that, I'm going to turn over to Josh and kick us off with your opening remarks.
Thank you very much, Colonel Haase. Thanks for the opportunity to address some of those points in your introductory remarks, and good afternoon to all. As Colonel Haase stated, my name is Josh Goodman. I'm part of the Pratt & Whitney team, and we work on propulsion solutions. Propulsion is not just main engines on fighters and bombers. It is also expendable and attritable propulsion for munitions. Our focus is on agility. Keep propulsion requirements to a minimum. Provide the lowest cost and just barely technically acceptable propulsion solution. Move fast, fail fast, learn fast, iterate quickly, mass produce. Scale both size and quantity. For instance, why spend millions and years to perform a full product characterization when a quick proof of concept can be performed for a few $100,000 in just a few months? Further, small expendable engines in the munitions space are the ideal place to innovate, test, learn, and scale in rapid succession. This agile process also builds extremely strong engineering talent and passionate engineers. But how will we do this? Let's start by pulling on the digital thread and exploring alternative manufacturing methods such as additive manufacturing. We can significantly decrease the lead time through exploring additive manufacturing solutions in place of traditional castings. The goal is to replace long lead time and poor on-time delivery castings with exact replicas manufactured via additive. We're testing parts that actually have superior material properties. Traditional casting manufacturing methods requires tooling. This tooling wears over time and requires manually intensive machining processes. In some cases, each individual casting must be machined uniquely to maintain proper wall thicknesses. This all goes away with additive. And we can cut down on part number counts too. We can replace labor-intensive assemblies with one printed part, improving quality and delivery. This creates ultimate flexibility to integrate small engines into compact spaces and then rapidly create derivatives. Next, let's pull on the digital thread. We've already demonstrated all the building blocks of digital engineering and manufacturing. Small engine programs are, again, the perfect place to bring them all together and run a fully digital program across the full life cycle. Small engine programs are shorter, less complicated, and less risky in both dollars and pilot safety than main engines. This is the perfect place to perfect our new digital systems. So we need to speak the same digital language in the industry to promote flexibility throughout the value chain. Digital means different things to different people and companies. We'll need industry panels and experts to opine on the standards. If it is the case that the government wants to own the tech stack, we, both government and industry, need to consider the ramifications on contracting vehicles, private investment, IP ownership, and IP security. I'd like to offer just a few more points to bring this all together. Let's start with risk tolerance. Combining tools such as digital engineering and additive manufacturing can promote rapid onset of configuration changes in a good way. However, this agile vision is only implementable and beneficial if we reduce requalification barriers and therefore costs. Reducing requalification costs necessitates a conversation on risk tolerance. Think about ultra low cost mass on target. You may be able to accept 95% reliability. This opens up a huge design space in terms of material tolerances and testing. And this requires a different design mentality, a different type of contract, and different measures of success. Lastly, on risk tolerance, different programs allow for different risk-based approaches. It should not be a one-size-fits-all approach. Lastly, systems integration will enable the next step change in performance and costs and are directly supported by digital engineering and alternative manufacturing methods. In just one example, we found we could improve the range 10% through just a small modification of the vehicle exhaust. 25% of the cost of small engines is in the external controls. We believe these can be easily integrated into the rest of the vehicle. For example, integrate the engine controller into the main controller rather than having a completely separate black box. Better packaging of the engine via additive results in smaller size, less weight, and more room for fuel, resulting in longer range. That's it for my introductory remarks. With that, Colonel, I'll turn it back to you, sir.
Great, thanks, Josh. Good thoughts, and we'll probably pull on some of those threads here with some questions. So over to next up, Storm and Norman.
Thanks, Haase. Appreciate it. So, I think everybody in the industry is listening loud and clear as our new Chief of Staff, General Brown, said, we must accelerate change or we're going to lose to the adversary because they're moving fast. I think we're all challenged, certainly on the DoD side. We know the budget realities are going to constrain not just DoD investment, but the industry's been hit pretty hard as well across the board with COVID impacts. So the demand on IRAD and the availability of IRAD is going to be constrained. So we need focused investments, and we really need to focus that on the programs of record. If I'm talking with our MAJCOM warfighting leaders, they're interested in delivery of capability and less on the endless prototypes. So I'm not saying that the job that our AFRL is pushing, and SCO and DARPA and the development of the new technologies isn't absolutely vital so that we have those LEAP capabilities. But we got to balance more on that delivering of capabilities to the airmen in the quantities that they need. To make that happen, we need really clear warfighting requirements. They're an absolute must. What target sets must the weapon hold at risk? That's a gap today. What weapon attributes are valued by the warfighter? So the size, what does it need to fit in, the weight, speed, range, those type of attributes. What threat environments being used to assess its survivability, because that goes into the design stroke. Make our threshold requirements, as Josh kind of alluded to, make those threshold requirements at a level that they address those exact warfighting gaps, and then set the objective performance per requirements to address the growth that we anticipate we'll need for this program of record. And then set design cost points. If it's a blank check, they're going to fill it with a lot of numbers. guaranteed, and it's going to drive out the timeline. So if there's a clear understanding on when it's required for the IOC and what that cost point is, I think that helps industry writ large get after the problem quicker. Here at Raytheon, we're focused on the digital design, I think like the rest of defense industry. I can say from internally, our investment is to increase velocity. So the speed of the capability of development, and then the efficiencies in manufacturing and supply chain, and then sustainment. That includes the additive manufacturing and automation all the way through delivery. For this to be effective, I think there's some big points that, certainly we on the industry side, and then certainly on the government side over to the Hill, the people who actually write the checks for us, we need to appreciate that the historical cost curves for learning that we've all known to come and love over time, those are going to change. So as we're going through the thousands of iterations in a digital twins world, we're getting a lot of that learning there before we go into production, before you're hitting print. And so I don't know that we're necessarily going to see in the future as steep of a learning curve as we've programmed for in a lot of the MDAP programs. We're going to need new regulation and policy to support the new process. Gone through many proposals since I've gotten out and been here with Raytheon, and they're immense. The amount of cost, time, and effort that goes into producing those 20,000 page plus documents that may or may not ever be read, it's excessive, and that drives a lot of time into the development process. So as much as we can take advantage of the tools with the Cloud One and Platform One, using the system integrity with that to make sure that we're protecting all the information, but use all that information that's readily available to satisfy the requirements of insight on the proposal, so we can streamline the proposal process greatly. I think that'll help. Acquisition strategies going forward, we need to be able to support the business case to drive competition. I know it's not a shock to anybody in industry, but I don't know of one successful defense corporation that is a for-loss organization. And so there has to be a business case that there's something on the back end other than the joy of getting to participate. And we have to be able to sell that internally to get the IRAD that we need to develop the new capabilities and to have that competition as we get into the e-weapons. And it's not just a build to print that we have to appreciate. And I know Colonel Haase and his team are looking at this with a laser focus, but it's a complete cradle to grave proposition. And so as we look at the various steps in the way we're running these acquisition programs, we got to factor in the facilitization costs. We have to factor in supply chain. How do we keep and maintain the breadth of supply chain so that we're not down to a single manufacturer for a given part? And then more importantly, how do we maintain the control over that production and the quality so we don't have the escapes all the way into supporting it for the sustainment so that we can support these weapons and these effectors as they're fielded. We found that the use of digital twins, they've been very effective. We've used it extensively in LRSO, and I can go into some of the investment that we've done in that, but it allows us to run thousands and thousands of iterations with design changes to see what doesn't work, what intended and unintended consequences or effects on performance can we see with a small change. And that saves a lot of time. And I know across all of our industries, we're doing that same thing. There's a few more critical elements in the e-weapons systems design. So certainly WOSA, MOSA, and maybe bias coming from the Air Force, but I think the Air Force is leading the effort there in developing that standard. I know across industry, we all like to say, yeah, we have open system architecture, but there's a lot of proprietary hooks in that. And so slapping the table and saying this is the standard, as Colonel Haase mentioned with the government reference architecture, but this is the standard so we can do that plug and play and we can make composable systems in the future so we can change out a propulsion capability if we have an improvement there. If we have a leap technology and guidance, we can change that out, plug it in, the interface works with the aircraft, and it's interoperable with the weapon because it's fully compliant. On the cloud one and platform one, getting that out to industry writ large. So, we're kind of at the cusp on this journey with the e-weapons. The platform one has been going for a little bit. You've heard Dr. Roper talk about it, certainly with GBSD, and we've also seen it with NGAD that he rolled out earlier in the year. It's time to accelerate that across industry for all the competition so that we're all playing on a level playing field and we're all using the same tools and we're adopting those early in the process. Ideally, I think we need access to that and to the government reference architecture and to any government approved tools prior to the RFIs coming in. I think we'll get a better product across the board and we'll be able to accelerate that source selection or down select if we're going to keep competition alive as we work in towards TMRR and eventually to a milestone C decision. Josh mentioned it, but the IRAD and IP protection. So, if a company is investing money in an IRAS because they're trying to develop a discriminating capability, and there's a reason for that. So they have justified the business case for that investment. So we need to work together as industry and the government on how we work that sharing of the data or how we protect that IP going forward, or if we can wrap that IPs, but in a fully WOSA compliant widget that can be a plug and play into any future weapon. With that, there are some opportunities for drive for standardization. So commonality and weapons data link, these are always the big cost drivers in any weapons development program. So the sooner we can come to a Air Force, at least, ideally a joint weapons data link that can be scalable, I think we're going to see costs go down and development time go down. Same thing with a secure processor. So every weapon's going to need that. And right now, if you've seen one, you've seen one. And quite frankly, that is probably an area where we can take advantage of the competition that Dr. Roper has been pushing and take advantage of the commercial industry to make that secure processor. It's going to be a lot better for the DoD as far as configuration management and trying to protect against threats. If you're doing that against 1, 2, or 3 that are scalable from platform down the weapon versus 30 different variants of a secure processor. And it gives us hope of keeping up with the threat with those secure processors. I think anybody who's been involved in either weapons test or weapons development can attest to the fact that our flight termination system is another one. If you've seen one, you've seen one. And the sooner that we can come up with a standard for that and we can make that available as GFE to all the manufacturers, I think we'll see a great reduction in cost as well as timeline and complexity. Everything that we do, it needs to be to drive down the development and fielding costs. And then the more we can standardize that from the data links to secure processing to the way we collect and use that data within a weapon system, I think it supports the Chief's vision for ABMS and JADC2 as well, because it makes a more common core of data that can now be correlated, fused, and used in that combined environment. All that said, we're working hand in hand with the SPOs and with the weapons POs as we all across industry begin to see weapons journey. I think digital engineering is going to be the forefront of everything as we develop this. We're building it into our existing weapons program. So Stormbreaker certainly has parts of that in it. Griffin, which is a smaller weapon that we work with AFSOC and SOCOM on, and then LRSO, the replacement for Alcom. Those all have aspects of digital engineering built into it. And we're doing that as well for our future weapons programs, as I know every other manufacturer is. So we're doing it on Peregrine, long-range multi-mode missile, and then our variant of the hypersonic cruise missile. I guess it's worth re-emphasizing that funding is limited. This is not just a government problem. Mom and dad are broke, charge card is overspent, and we've got to think as innovators now to find real solutions. We can't just spend our way out of this. So for industry, we have to have a rock solid understanding of those requirements, like Colonel Haase talked about, and more importantly, investment priorities. So when we mention the Air Force futures, it's going to be critical that we involve industry so that we're laser focused as well on our investments, so that we deliver the right set of capabilities to the warfighter on the timeline that they need them. For that to happen, we need open, transparent, and consistent engagement between AFRL, the weapons PEO, up in the Pentagon with HAF and SAF on the acquisition side and on the requirements side, and the MAGCOM warfighters as well as industry. We got to attack this as a team. We're all part of the same team, and if we're going to keep pace with our adversaries, we've got to work together. You mentioned it. I think one of the biggest challenges, and it remains a challenge, and it's not due to any lack of trying, and it's on the contracting side. I think we get beat up across all the services by the Hill because they get frustrated. They appropriate money. They expect it to be allocated and spent because we did such a great job on the service side advocating for it to get authorized and appropriated, so that they expect us to execute that funding that they worked hard to portion out from the national treasury for us. And so the faster we can get these programs on contract and we can deliver that capability, I think the happier they'll be over on the Hill, and the more likely our programs will be to survive. Certainly helps with execution. It doesn't put us at a 4 to 5 month catch up because we're doing contracts awarded in Q2 or Q3 or Q4 at the worst. So we definitely have to speed that up. I said I'd talk to it. So on our investment in DE within Raytheon Missile Defense, so we got almost $200 million going in just for our business unit, close to $400 million this year across Raytheon Technologies. A program that we have worked LRSO, we've spent $430 million in that alone, just in digital engineering. Not because the Air Force drove us to, we benefited from it, but because it made us more efficient. So there's a definite business case benefit for industry doing this, and there's absolutely a benefit for the warfighter. So with that said, we'll hand it off back to Colonel Haase and look forward to the questions.
Excellent. Thanks, Stormin, for hitting a number of those key things. And I think you kind of addressed one of the questions that was in there about IP, but I'll come back around to that one to discuss too. So let's go next to Terri Quick, Elbit. So Terri, take it away.
Great. Thanks, Gary. Good afternoon. Thanks to AFA for hosting us today, and to Colonel Haase for the task of growling the cats with all the industry reps today. Elbit America is very proud to be the seeker provider for large portions of the U.S. precision weapons portfolio. Today, precision weapons are preferred in a wide range of applications, as everybody on this panel knows. However, as AFA has been showcasing 30 years ago, as Desert Storm was unfolding, precision was just emerging. And while those weapons at the time were a small percentage of the overall weapons dropped, the ability to ensure a correct target was engaged was a game changer. And over the past 20 years, as collateral damage concerns were front and center, increased precision also became a driving operational imperative again, but initially it was too expensive. So Elbit's very proud of the fact that our laser seeker solution filled that gap in an affordable way and ensured pilots could have confidence their weapon would hit the target within the collateral damage expectations. And since that time, our family of seekers has continued to evolve and change to meet both current and emerging needs. So going into the new threat environment, we know that there's less certainty that a particular weapon's going to be effective, either because it's taken out by a countermeasure or the target moves or adapts inside the decision space. We absolutely want to give operators confidence that their weapons will be effective every single time. And we're very focused on user-informed seeker solutions that deliver confidence. So as we look into the future, we know the next fight won't look the same and will challenge us in many ways. I heard reference earlier today to the OODA loop. Maybe the new one is a defensive measure or a countermeasure and a countermeasure cycle. That loop is accelerating, and the time for responding with a meaningful solution, both offense and defense, in each cycle is shrinking very rapidly. Survivability is going to demand new variations of time-tested approaches. We've heard reference to that already today too. Speed, mass, self-protection. Weapons overall will redefine what smart means. Seekers will need to be much more than just the eyeball for the weapon, need to be more intuitive and part of an integrated sensor suite. Networks and connected systems will rapidly pass data between nodes, update with new intelligence in flight, provide better situational awareness overall. So how do we prepare for that? First and foremost, we at Elbit America believe digital engineering is more than a buzzword and actually holds promise to allow much of what is required to be ready. Done well, digital tools and robust digital twin models allow you to iterate way faster, more comprehensively, drawing conclusions and making updates far faster than in traditional approaches. Future approaches also demand designs that are deliberately more open and modular because updates and improvements must be inserted rapidly to keep up with the threat. Again, that will be dependent on digital definitions of interfaces between systems, but adhering to an open approach allows the Air Force to pick the best of breed from across industry, multiplying the impact of new solutions. In other words, a digital approach goes far beyond just designing the hardware. It will feed all aspects of how we approach system development, testing, training, fielding, operating, and sustaining. Robust digital environments based on shared standards and expectations will be foundational. So how is Elbit America approaching this? We're investing in technologies that will improve seeker capabilities in the precision strike area that take advantage of and benefit from an open approach. We're not a big end-to-end weapon provider. So our seeker has to play with any weapon, which we believe is critical for future upgrades and adaptations to continue staying ahead of the threat. We're also focusing on both hardware and algorithms that allow the seeker to understand a variety of environments and adapt real time as the situation changes. We're exploring ways in which alternate payloads can be integrated or take advantage of new seeker technologies, more networked, more targets per weapon, weapons as a sensor network, and additional benefit from an open approach. We are also exploring how to model the weapons worldview and interactions accurately and effectively to aid in testing and AI training. This behavior is historically resistant to modeling, and we believe this environment will be absolutely critical. And we're very focused on affordability. Mass is only possible if it's affordable. So again, thanks for the chance to be here today. I look forward to hearing from the other panelists and for your questions. Over to you, Gary.
Thanks, Terri. All right, last but certainly not least, just by virtue of being the last name with starting with a W, so I went alphabetical by last name. So I'm going to turn over to Dave Winebrener for his comments, and then we'll open up into questions. Go ahead, Dave.
Thanks, and first just want to share a thanks also for AFA for hosting and to you, Colonel Haase, for putting on this event. Also appreciation for the Mitchell Institute and the good work they do to educate the force and also those of us in industry, helping to understand some of the challenges we face. And I think, in prepping for this this panel, trying to think about new insights to offer, but just rereading that Accelerate, Change, or Lose, I think that really sums up a lot of the challenge that we face. And so while I'm certainly not going to be more eloquent than what's in there, I think that's kind of the starting point, at least for me, to kind of define what we're accelerating to. So obviously it would echo the concerns in there about the consequences of losing the high-end fight, and just being very concerned about making sure we're addressing that. Obviously spent a career in the Air Force trying to develop technology solutions, but also seeing the need to really address some of those force structure problems going forward. So I think within that document, one of the key points is that those decisions on capabilities have to be informed by how they fare against our understanding of the competitor's theory of victory. And so kind of going to that requirements piece of understanding how it's going to work against the adversary, there are things we can do to accelerate, to go faster, like digital engineering, and I think that will be key to doing things faster. But more than that, we need to know where we're accelerating to, and doing the right things faster as well, and defeating those theories of victory. So I think there's areas that I see a lot of encouragement in hypersonics, that used to be more in the R&D realm, and it's great to see weapons getting closer to actual fielding, and the capability that will provide operationally. Seeing tailoring of operational weapons like JASM, now having more of an anti-ship capability and extending the range, I think that holds a lot of promise with that against the future threats. Even seeing more shooters out there with the F-35s continuing production and B-21 getting closer, I think that helps a lot from a munitions perspective, that there's just more in play that can deliver our weapons. ABMS, obviously, it's been mentioned before, but that's just going to be critical to connecting those sensors to shooters and making sure we're making the most of the information that's out there. I think unmanned, you see breakthroughs with Skyborg and Gremlins and Valkyrie. I think understanding not just the technology, but also how we will fight those and the con ops that opens up going forward will be fantastic. But I think personally, you know, one of the areas I see most promise in is these miniature munitions. It shouldn't be really surprising, I suppose, at some level that with the other advances in miniaturization across consumer products and other areas of the military, that there could be a similar trend in munitions. But I just see a lot of potential for increasing the volume of fire, increasing the lethality, if we're able to really capitalize on that miniaturization. And I'm still impressed by a full load of SDB on Strike Eagle. Just seeing that belly flash up is a powerful thing. And you know, congrats to the Raytheon team for IOCing with Stormbreaker here as well. That's a huge capability increase as well, and a much more robust kill chain. So I think we're trending towards it. I heard an update from General Pringle this morning, you know, kind of the progress on the Golden Horde as well. So good to see that those developments are taking place. I'm not convinced a 250-pound class weapon is the end of that trend either. I see smaller munitions, smaller UAVs, and this broad category of air-launched effects. You know, I think for the past decade or so, when people talk about small weapons, they really start thinking about counter VEO, and there's tailored effects that have been very effective there. But as we look to deliver that mass going forward and deliver that swarming, and we anticipate challenges for even getting aircraft into that next fight, then we really need to insist on getting the most out of every payload. And in some instances, that's probably a MOP or a big penetrating type weapon. Sometimes that's standoff or hypersonic weapons. But I think a lot of times that's also going to be a swarming capability and just delivered in mass. So lots of exciting things going on in development. I guess I'd leave you with one final thought, kind of an adaptation of General Mattis's quote and his advice to be polite, be professional, and have a plan to kill everyone you meet. And I think, you know, for a lot of us, our mind goes to Afghanistan or Iraq and a patrol on the ground. And the advice is don't go out and look for a fight, but if the fight comes to you, be prepared to bring immediate lethality. Just very quickly, very overwhelming force. And this next fight, as I understand it, is not a gunfight against an insurgent, but we need that plan to kill things, and it's tanks, it's TELs, it's radars, it's ships. And that immediate lethality is going to make the difference. And like General Brown pointed out, you know, those consequences are profound. So that's how I see it. Back over to you, Colonel Haase, and appreciate being a part of the discussion here.
Yeah, you bet. Thanks, Dave. And thanks for that quote there. That's something that I like to tell folks too, that with munitions in particular, but just broadly our capabilities, when we throw around the word deterrent, sometimes lots of people think more from the nuclear strategic perspective, but even from the conventional standpoint with our platforms and network capabilities and our munitions, I think can have a deterrent effect. But then also as we move in that direction, it's first hopefully deterrence, but then having actually that capability that we can keep that fight unfair in our advantage should it turn hot there. So thanks everybody for your opening comments, perspectives there. So I've got a few questions here, and what I would like to do though is go back to one that was here. Storman, you kind of hit on a little bit about IP ownership, and so I'm just going to see if anybody else wants to jump in on this. And the question was, is it possible to expand on the issue of IP ownership in the context of modular open system architecture and government reference architecture? Anybody else want to comment on?
Yeah, Gary, I'll take a stab, and I think much like Josh kind of alluded to from the Pratt and Whitney, right? We're not the full up entity, right? So when you play in this space as a contributor to an all up round, there's always considerations, and I actually think that defining those open standards, and at least the way that I think about it is, you know, when you plug in the speaker into your laptop, or you plug in the charger into your phone, you don't have to know how the phone interprets, you know, that signal. You just know that the phone knows there's a charger there, right? So all that IP that's inside the phone still exists inside the phone. There's just enough of a connection there that they know how to talk to each other. And so I think there's room in an open kind of a architecture and an open kind of an approach that can allow companies who've made those kinds of IRAD investments, who've put specific company secret sauce into the mix, there's certainly room for that that kind of an approach. So I think that's how we think about it. I'm open to others' thoughts as well.
Yeah, I mean, I think companies are going to invest where they see opportunities. And if they're going to invest in areas where long-term IP ownership is what I'll say risky, and there's not going to be a return on that investment, I think we have a challenge. I mean, I talked about the tech stack. If we're going to be able to fly, digitally fly an engine into a missile with all of the various counterparts, and that the IP surrounding that tech stack, that missiles environment, it needs to be considered from an ownership perspective. And if the government desires to own that, and I think Dr. Rober talked a little bit about this in his first paper, we have to look at what we're willing to spend on acquisition costs. I'll say, upfront acquisition costs, a little bit different in the munitions world versus some of the other product spaces, just regarding the non-existence of an aftermarket, which significantly changes the business case as industry looks at it. And so, I think we've got to get that balance right. And they're like many situations in life, we're not necessarily afforded our cake. We want our cake and we want to eat it too, but that's not always the real world. And I think we've got to face into that into that headwind, that there are upfront costs that are going to be required to be funded if long-term IP ownership for down the road flexibility and maturity and iterating is desired. Over.
All right, great, thanks. Let's see.
There was a quick question in there. Sarah Sirota asked about the first flight demo of Hawk. So Raytheon's offering of that. Obviously, we're in a competition with another manufacturer is doing great as well. We've been ready for a while. We're waiting on the launch platform and range availability. As you can imagine, pretty complex house of cards to put together a long-range hypersonic test from an airborne platform. So, when we can get on there, which is going to be fairly soon, I think right around the same time as the company we're competing against, but we're ready for flight test, and I think they are as well. So it's a good and exciting time. I look at hypersonics as great attribute, it goes fast, still weapon. And whether it's big, small, what's some more value to me, having been through weapons school, is what target set are we going to hold at risk? And if it's going fast, why? So we're cutting down the target engagement cycle. That's a good thing. Helps us speed up that prosecution of fleeting targets or time critical targets. It can also help with survivability, and it can also help with weapons effects. When you bring, even if it's a big hunk of Inconel coming in, non-explosive, still has a pretty good kinetic effect on a target when it's hitting at the speeds that those can fly. So we're excited about it, and I know the Air Force and the customer is very excited about it, and look forward to putting out good positive news from us in the competition that America is not only in the game, but we're beating our adversaries.
Thanks for answering that one. Going back to talking a little bit about open systems here too, I had a question about the UAI, Universal Armament Interface, has been in play for a decade plus and started as an open systems idea to be able to get in, more so for integrating weapons onto platforms and being able to do that much quicker. But kind of the question is, how is today different than where we've been before on implementing open systems? Kind of a history thought and perspective going forward.
So Gary, I'll jump in again. So I think the difference is when UAI initially was a vision, it meant a lot of backward compatibility to all the platforms that suddenly had to have UAI in their aircraft. And that's always been the challenge, right? These new ideas come along. And if you're an existing platform and you are already fielded, how do you get that new capability in there? If you're with a new platform, you can kind of bake it in, and going forward, it becomes the standard. I think fundamentally the difference is that the conversation around open systems in general and the need for the kinds of things that UAI envisioned, I think is much more mature, because I think there's a much better understanding across industry and within the government of the value of having that kind of an approach. And so that to me is the biggest difference. Is it was a more niche, I think, back in the day, but still a great idea, just hard to implement. And that, I would say, same thing probably for open systems today, right? And just the conversation we had about IP, how do you do it? How do you do it in a way that's cost effective, both for industry and government? How do you do it so it's sustainable going forward? Because you can be open today and suddenly tomorrow you're Betamax, right? And so you got to make sure that, you're constantly thinking about how do you continue to keep those standards relevant? And I think that's worthy of a robust conversation between industry and the government.
Yeah, I think you hit on something there too, Terry, that I was thinking of, and I was also brought out here too, that's a key aspect with the open systems, and especially as the government moves into wanting to own those interfaces and GRAs, is that you have that partnership attitude with industry, that we're not developing those on the government side and pushing it on industry aspects, but it's trying to pull in all of those insights and expertise from across industry as well, and so that we can get that buy-in also for those open systems and those interfaces.
I think the other aspect of the WOSMOS, which is a little bit different than the UAI, is, for it to work, for it to be that panacea, we have to have the open system OFPs in the platforms that these are going to come off of. I'd say, a huge part of the fielding for whether it's a block upgrade or it's new weapon system, it's running all the integration tests with the existing platforms and future platforms. And so, through F-35, not everything we have legacy up through that, not open system yet. And so there's a whole lot of integration tests, a whole lot of software labs, and it's a year-plus process, which drives a lot of DT flights and a lot of OT flights. I think the promise of truly open systems from the weapons through the platform is that now in a model-based environment, we can do a lot of those elements that we would typically do in DT and OT in a model. And we can validate that interface through the model, and then go out for the actual proof of the effects in that interface in a much more time constrained DT and OT process. That's the hope anyway.
Well, I know from go ahead, Dave.
Sorry, just one other point, and absolutely concur on the need for software in the aircraft and the logical interface, but there's also a mechanical interface issue. If we talk about operationalizing the swarm, there's a different interface that we need to figure out, perhaps that doesn't look a lot like how JDAM or other weapons or AMRAAM or AIM-9X, these smaller weapons. I know there are some demos that come out of chaff flare dispensers, and you get what you can with what's available. But if we're really trying to innovate in different ways with different form factors, there's also that aspect that would need to be addressed.
Yeah, so that's what we're kind of hitting one of the questions here about changes to DTOT with these dispute process, and so there are certainly aspects that still need to have that kind of testing to do. Models aren't necessarily always perfect and right, but it's that testing that can help validate those models. And as my brothers and sisters in the test community will kind of say, it's actually, these are all tools and aspects that help us narrow in on what more specifically, what do we need to focus that attention on where the questions are, or the most needed amounts of test on a system, and so we can better scope and narrow what it is that they need to look at, and then gain back some of that speed by having that focus. It doesn't negate needing to still do testing, but it helps to be a little more focused and streamlined with that.
Yeah, Gary, and I think, go ahead, Stormin.
I was saying the other piece of that. So as we do the WOSA and we do the digital engineering, we talked to sustainment. I think it's important to touch on what's meant by that. So I'm very much into the keep it simple process, and I think across all of industry we are. So it's keeping that MUNS tech sergeant that's out there as a level 7 trying to train all of his level 3s to build up these munitions. So making it easy on them, making it easy to store, making it easy to put together, making it easy because they are composable to pull a bad part off and replace that, or we can change out propulsion if we need something longer range. And then also part of that sustainment is how do we work that interface with the user? So how do you do the mission planning? How do we make that as simple as possible? How do we make it as common as possible across a family of weapons so you don't have 20 different standalone computer systems back in a weapons vault with more training requirements and more configuration management requirements than you could ever handle. And so it's all part of that, trying to make that foresight commonality while still delivering the technological advantage. Sorry, Terri, back over to you.
I was just going to make an observation when we talk about the testing and the modeling. And I think one of the things that we're starting to pull a thread on, I think, is, weapons operate in a very, very intensive, dynamic space, right? And so the ability to be able to accurately depict that in a model and with algorithms and AI and ML and everything that we're talking about putting into these weapons to make them do all kinds of things we've never envisioned them doing, right? From the swarming that Dave's talking about to the hypersonics, and everything in between. And thinking about how do you know when the AI algorithm is good enough? How do you train it? How do you test the training that the system has had? And that really brings you full circle, I think, back to digital engineering and solid models and twins and things that really allow you to capture the characteristics of the systems that you're trying to design, and doing that faster, sooner, earlier, often, all the things that are, all about good systems engineering, right? That's fundamentally what it's all about. And then in theory, that can inform, just like Gary said, right? The edges of the envelope that you really need to go test, because everything in between, with good confidence, what you have confidence in the models and that they are representative. And I think that is really going to be necessary, because we are not going to have the time or the range space or the money to be able to go out and do live shots on everything we'd like to do live shots on.
I think really well said, Terri. I mean, I think that the old adage, a test is worth 1,000 theories, or when there's a conflict between a test and a theory, you got to go, take a look at believe the test, not the theory, right? But we're really bringing these concepts together with digital engineering these days. And we're able to test the theory in this digital space. And we have got to trust those models, our engineers and the math behind those models, to make us more agile, to make us more efficient, to be able to iterate quickly and to scale quickly and to do all those things. And until we wholeheartedly buy into that environment, I think we're going to be fooling ourselves a little bit, and we will remain in the mindset of the past that we want to put everything on every wing and drop it off and see what happens. And I think we're better than that these days.
Great discussion. All right, we are narrowing in, about 5 minutes left here. So I would like to give a little bit of time for each of our panelists for any, take a minute for any closing comments, and let's go reverse order back around. So Dave, I'll start you off here. Go ahead.
Sure, and again, thanks for being able to host this, and appreciate being part of the discussion. I guess I just go back to the Chief's paper and that concern that good enough today will fail tomorrow, and we're absolutely here to help the Air Force succeed in the future. And again, appreciate the time.
Excellent. Terri.
Thanks, Gary. So I just appreciate the willingness of the fellow panelists to be in a conversation like this, right? I mean, I think that's doesn't get enough credit how much industry collaborates and cooperates behind the scenes and with each other and in various teaming arrangements. And I think that is also a powerful part of our success message going forward, right? Is that we have the best industry in the world, and we just need to figure out how to harness that. Again, we've talked quite a bit about, the open architecture, the digital engineering. They sound a lot like buzzwords, but like I said, I think we fundamentally at Elbit America, I think we are absolutely embracing them because we see that as fundamental, particularly for a company like ours, right? Where we do a lot of subsystems for a lot of big primes like Raytheon. And so for us, it's absolutely critical that we know how to interact with and integrate with lots of different big primes. And so that it's kind of baked into how we do things. So I absolutely think it's the right thing. And I hope we can embrace it more fully. So thanks, Gary, for giving us the opportunity to talk today.
Welcome, Stormy.
Yeah, Terri hit on a great point. As we get into digital engineering, we go on this journey. It's absolutely essential that it's not just the primes. It's all the way through supply chain and to those teaming agreements. We've all got to be on the same models, or at least common models, so they interact with each other, so that you have confidence at all steps in the design through production that we're working off of common data, and that we can build the confidence in the models. I'm excited for this. I've been certainly working it while on active duty, and excited to be part of it with industry. And we have great partnerships across all of industry. I mean, bunch of great, very dedicated employees that are absolutely passionate about their work and want to do the right thing for the warfighter to make sure they get the best capability. And thanks for the leadership you're providing the FRL, and most importantly, I look forward to doing this all in person very soon. I'm tired of virtual Zoom. So thank you again for hosting us.
You're welcome. I definitely agree. All right, Josh.
Just want to touch on people quickly. I mean, behind these models and tests, there are people, and there are great engineers. And as we look at these really tough challenges, it's those people that love to stare them down and really go fix them. And we've got great people, in industry collaborating across across public-private lines, across company lines. And, I really enjoyed the discussion today. Look forward to continuing to collaborate across those lines. And once again, we'll thank you, Colonel Haase, and the AFA for the opportunity here today.
Thanks, Josh. Thanks, everybody on the panel. Thanks for all of the folks that dialed in, listened in. And thanks AFA for letting us talk about fun topic here of munitions, but I will echo there, Josh, some things that we've talked about there about the people, and it is pulling the people together across government and industry and across the country to be able to keep us ahead of the tech curve and ahead of the adversary in providing those capabilities that we need as a nation. To keep us on the forefront of supporting our needs and hopefully keeping as peaceful a world as we can. So with that, sorry we couldn't get to quite all the questions there, and hope that you all enjoy the rest of the other sessions that are going on here with AFA, and stay safe and healthy. Have a great rest of your day.